Choosing the right software architecture when you want to start a software project is so important and crucial because when you don't make the right choice, you will have a lot of issues later on. You will have some flexibility issues, you will have difficulties maintaining the project, you will even have some performance scalability issues. So you need to take time to basically plan and choose the right architecture depending on the project and the criteria. And I personally had to deal with this when I joined a brand new team, and they had a software application that was literally a mess. It wasn't built and it wasn't planned in the right way. And we basically had simple task which takes a lot of time, and we basically had to do a total refactoring of the application to make it possible to work on it. And as you know, refactoring takes a lot of time and also takes a lot of money because when you do refactoring, you're basically not generating any business value. And as you know, when you are not generating business value, the business are not very happy with that because they feel like they are wasting money and they are not getting any value back. That's why always take your time when trying to start a project. Take a little bit of time to examine your project, examine the people gonna be working on. Is it gonna be worked on by only few people or by large teams? And then make the right choice. And one of this architecture that are very common in the business world in companies is called hexagonal architecture. And this is the topic of this video. We'll talk about hexagonal architecture. What is it? What is this architecture? And we will also see why would we even want to use it in the first place. And we will see a real example of its implementation using Spring and Java. Okay, so let's start. Hexagonal architecture is simply, obviously, a software architecture. And what we mean by a software architecture is simply just a way to build your project and structure your project. And the main logic behind this architecture is the separation of business and core logic from the external. And what I mean by the external is anything that do not have to do with the business logic. For example, where you store your data. It doesn't matter for the business where you store your data, in a database or in the file system. And also, it doesn't matter for the business what initiate the interaction. We can get a request, for example, an HTTP request from a browser, or we can get some command from the CLI. So this is what we call the external, and the basis of hexagonal architecture is this separation of business from the external. And we achieve this separation by using ports and adapters, right? And we'll see what is this ports and adapters. Ports are simply interfaces that define the communication between the core application and the external dependencies. So let's see this graph right here. So right here we have our application. Let me get the pen. Okay, wait. Good. So we have our application right here. So right here we have all the business logic, pure business logic. We don't have any external dependencies. And right here we have dependencies from two sides. From the input side, like browser or mobile app or some CLI. And we have the output side, which things like database or the file system. So how does the application communicate with the outside? It does it through the port. So the port is basically the gateway for the application to communicate with the external. For example, in this port, we can have something like an interface, a Java interface that have a method called get products. So basically, the application use this interface and use the method get product. Okay, so it's basically the way we communicate with the external. And now we will see what is adapters. Adapters are simply implement the output port and initiate the interaction with the application through the input port. So adapter basically have two distinguished job. For the output side, what we have to do is adapters actually implement the port. So as I said, application for example, want to get some product, it will go through the port. And the port, for example, as I said, is just an interface with a method called getProducts. And the actual implementation of this method getProducts will be done right here in the adapter, depending on which adapter, for example. For example, the database adapter will implement the port to get the products from a database. And as I said here, and initiate the interaction with the application through the input port. So as I said, the adapter in the output side implement this port, and the adapter in the driving side or the input side initiate the interaction. So think of this like some controller, for example, in terms of, for example, a REST controller. So a REST controller is the one that initiate the interaction. For example, we receive an HTTP request to get products. So this controller initiate the interaction and enters the application through the port. So inside the controller, for example, we will have a method that we are getting from this port, for example, get product. So we basically enter the application through the port. So basically, this is the two different adapter that we have. We have the input adapter that initiate the interaction and enter the application through the port, and we have the output adapter that implement this port. And we can have as many adapters for a port. For example, for this port, we can have an adapter for the file system, or we can have an adapter for the database. Same thing right here. We can initiate the interaction with a web browser, a mobile app, or maybe a CLI. It doesn't matter. For the application, this is all is external. The application do not care about who or what initiate the interaction, and also do not care where we store our application. The only thing that application cares about is the logic. And when it wants to interact with the external, it uses these ports. And this is the beauty of this architecture, that we only focus inside on the business logic, and outside we can do whatever we want. It's irrelevant for the application. And the driving side or the input side starts the interaction. As I said, we can be a REST controller, a CLI, a cron job from the adapter to the core through the port. And the driven side or the output sides wait for the application core to call it database, for example, from the application to the adapter to the port. So this is literally what we said. We said that the adapter initiate the interaction and go through the port to the application, and the output side waits for the application to be called, and it's always called through a port. Always remember, application communicate through the port. It doesn't communicate directly with the adapters. It always communicates through the ports. And this is basically just a conclusion. Inputs arrive to the application through a port via an adapter and allows output to be sent from the application through a port to an adapter. It's very simple. This is the main main idea of this architecture. The adapter start the input adapter start the interaction. It enters the application through the port. The application, when it needs some data, for example, we need some product, for example, we go through the port to the adapter. And that's pretty much it. This is literally all you need to know about this architecture. This is the only thing you need to remember. And right here we'll see some reasons why we want to use this architecture. And first thing first is isolate the business logic from external dependencies. As we said, it's very easy to test because when you have our application separated like this, you can easily test it. You just mock the ports or the dependencies, and you simply test the logic in your application. It's very flexible to change. For example, in the start, we were basically storing our data in a file system. Later on, we want to change it. We want to store it in a database. It's literally just a little change. We just change the adapter. Instead of using this adapter, we use this one. we don't touch the application when we will not touch the application. We just change the adapter. It's very, very easy to change. And we can make these changes literally in in a simple change. We won't have to make some huge change. It's very flexible to change in technology agnosticism. As I said, the application do not care about what external dependencies are using. It's very easy to maintain. This is a very big point. Very, very easy to maintain. You want to make some business logic, you make it right here. You need to change the initiating part, for example. You can make changes here and the outside. It's very easy to maintain and great for complex project. When you have large project, it's very good to use this architecture. And the typical layered application can have leaks. And as you guys know, layered application architecture is very common when we have presentation, business, and persistence layers. And we can have some leaks. For example, in the controller, you can directly call, for example, your repository to get some data from the database. And with the hexagonal architecture, we assure and we force the developers to use always to go through the port. We don't have direct communication uh, between the external and the application. We always go through the port to enter the application. Now we will see a real example of this architecture using Java and Spring. So let's go to our editor. There we go. So right here we have my project, and if we go to the source, we can see uh, some main packages. So we have the adapter package, we have application package, we have config package, and we have model package. And we will go through each of these packages. So let's go back to the uh, to the to here. And what we said that the adapter in the input side is the one that starts the interaction. So this is literally what we have here. We have in this here adapter in, and we will go to the rest package. There we go. So right here, this is literally the adapter in the input side. Think of it. And in this case, we have a product controller. It's a REST controller, right? And what do? We want to get some products. We want to return the list of some products. In how we go to the application, we go through the port, always. We always go through the port to enter the application. And this is literally what we do. We have a products port, get products. And if you go to the products port is just a very simple interface that has this method. As I said, ports define the interaction that the application will have with the external. So we have this products port that define the interaction that the external in the input side have with our application. So in the product controller, we use the ports to communicate or to enter the application. Now we will have the implementation of this port. In the implementation of this port, it's gonna be simply a service class inside our application. So let's go to this implementation. There we go. And this product service exists in the application package because the implementation of this port exists inside our application. So we have the product service implements product port, and right here is the implementation. And usually right here we have business business logic. So right here you have all your business logic. And what I do right here is just simply, it's very simple method. I just get products from a repository. And as you might guessed it, product repository is also just an interface. It's our external port. So when our application want to communicate with the output, we always, as I said, we go through the port. And this is the port in our case. It's called product repository, which have this get products method. So if we go to the code, we can find that this we have this product repository inside the package port out. So it's literally our port from this side. So when the application wants to communicate with the output side, we always go through the port. And where we can find the implementation of this port is found in the adapter side in output. So let's go right here, adapter, out, and there we go. This is the product repository implementation. And we have this simple class that implement this product repository, and we just override this get product method. And in my case, I just mock some products that I created. Obviously, in a real application, you will have to use some GPA or something, but this is just an example, and I just mock the product. That's pretty much it. So if I run my project, let's wait for it. Uh, okay, so if I go to localhost products, we can have that I returned this product that I have here. And that's pretty much it. That's literally it for this architecture. So to repeat, the input side starts the implementation. The adapter in the input side starts up the interaction. In our case, it's the product controller. To communicate with the application, it needs to go through the port. In our case, this is the port, product ports. And then we implement this port inside our application in a service. And this is what we have right here. And inside the application, we have all the business logic. So in these services is where we have our business logic. And another thing that I forgot to mention is inside the application also we have the models. And right here I have them in a separate package called model. So right here I have very simple models that you can have in this package. And then when, for example, in a service, you need some information from the outside, from the output side, you just go through the port to the adapters. And this is what we did here. We go to the adapters, and our case is the products adapter, to communicate with the external. And I use this implementation. And I don't know if you noticed one thing in this application is in the application package, I have no Spring annotation. So I'm not using anything that has to do with Spring. For example, the ports are simple interfaces. The service are just simple Java class. It doesn't have any Spring annotations. And also the models are just simple Java classes. And that's done in purpose. We want to keep our application pure. We wanted to keep it pure Java. We don't want to have any Spring, any other framework. We want to have them as pure Java classes that contain our business, right? But obviously, it won't work because we need to have our beans created for us. And this is the reason why we have this config package right here with this config class. And right here we define our beans. And the first bean that I define is the product service bean. And right here I just simply return this product service. I create the product service bean. And right here I create the product repository bean by using this product repository implementation. And this is what allow me to use Java inversion of control principle using this config file while also keeping my application clean with no Spring annotation. Some people actually use the Spring annotations like service inside the application. You can do that, but personally I prefer to keep everything related to Spring outside and just have my config class outside. It's just me, but obviously you can do whatever you want. Another thing is, for example, I no longer want to use this adapter, right? I want to use this adapter instead. So how do we do that? Because as I said, for the same port, we can have as many adapters we can. So it's pretty simple. First, you need to define the next adapters. And I already did right here. For right here, I have product repository implementation number 2, for example. And this time I mock five products. So I want to use this adapter instead of the first one. How do we do that? Very simple. I just change the bin definition. So here in the product repository, I use the product repository implementation 2. And we will rerun our project. So let's check the products. There we go. So right here, you can see that we have 5 products and we are using the second, we are using this adapter. That's why we said that it's very easy to, it's very flexible. We can change the adapter as we want. We just change what we want to use, either this one, or we can even add another one if we want. It doesn't matter. And same thing for the driving side. For example, right here we are using the controller, but let's say I want to use, I don't know, I want to use the CLI. So we just go to the adapter in CLI and we define a simple class that implement command line runner. This is in Spring. And what does this uh, class do? Basically, when we run our project, we want to get products using the ports, obviously, because as I said, all the adapters, it can be a REST controller or a command line. We always go through the port to the application. We are using the ports again, same thing as we did with the controller. And this time we just print the product in the console. We use the system out println to print the products in our command line. So I will just add, sorry, I will just add this annotation component to basically tell Spring that I want to use this command line runner. I rerun my application. And there we go. So as you can see here in the command line, I have this product printed in in the console. And this is an example of using another type of adapter in how flexible the hexagonal architecture is. I can use simply create another adapter that initiate the interaction, and I won't have to make any change to the application. As you saw, I didn't really touch the application. I just changed the adapter, and that's pretty much it. I won't have to touch the application, and the only thing I need to do is to call the port, because to enter the application, we go through the port. So that's pretty much it. I hope this was helpful for you, and thank you.